Oh, my belly full. Got some Panda Express. Whew. I am stuffed. Let's get this loaded up. Bow. Okay, cool. Are we live? What up, everybody? How you doing? Um, Hope all is well. We are back here today. Oh my god. Mouse. Sorry, y'all. That was annoying. Let me go ahead and plug in my AirPod case. Okay, cool. Okay. Yo, Chris! Yes. Happy you could catch the live too, man. That's awesome. Thanks for coming in today. Thanks for being able to set some time aside to join me and study alongside. You're awesome. You know, time is the most valuable thing in the world. So the fact that you're spending it with me here says a lot. So thank you so much, and thank you so much for trying to better yourself and work hard. And at least that's what I'm trying to do, and hopefully we can capture that. Welcome. Hey, Nebula. Today's your C exam. Oh, good luck, man. You got it. Um, Quickly binge read watch my C program, my modern approach watch alongs, my read alongs. All right, you guys, what's going on? Today is going to be C programming, a modern approach. We're gonna be jumping back into chapter 7. More specifically, we're gonna need to do some stuff here. Um, to set this up. Let's kind of make this smaller. Okay, let's get into our chapter here. Oh boy. 6 here, 7. It's been a couple of days here, so hopefully we can remember some stuff. But we finished the exercises last time, so I was thinking about taking a stab at maybe completing. We've got 15 programming projects, so I was thinking maybe we complete like 7 or so today, and then or maybe like we go until about like 8:30. We go for like 2 hours, and then I hop on my gaming PC and we play a couple games of League to just wrap up the week. Kind of, I like to, we have to reward ourselves. I think it's good. I've been trying to, I went pretty hard, like in like no gaming, no anything for the first year of learning, and it was really, I did learn a lot really fast and stuff, but I also, I feel like I didn't have as much like fun like personally, and life's too short to really like limit yourself of anything, any sort of outside pleasure that isn't work related. Like, I don't know, I constantly go back and have this debate with myself. I'm like, okay, I like, because really like video games and like people that grind for rank and stuff, which I do like. I have this like desire to want to rank up, but at the end of the day, like your rank just really doesn't mean anything, like unless it's like personal. So it's just like it doesn't really impact society at all. It doesn't really mean many. I don't know, but so but then you get enjoyment out of it. Anyways, whatever. We're rambling. Anyways, let's get into this here. So we are in the programming projects here. So we need to go ahead and set up our non-nerd hobbies. Is league considered non-nerd hobby, Tim? I don't think we've broken out of that spell. We're not like rock climbing or anything. I used to rock climb a lot in college. I got shoes and everything. But 'cause my college was right there in like a canyon, and so there's a lot of routes. Actually, I would do a lot of outdoor rock climbing, not indoor. Um, I would go quite often, at least like once or twice a month with some friends. But that was a long time ago. Grow up fast, man. Oh, jeez. Okay, let's get into this. We got to get moving here. So we need to do our thing here. So we got to say for, we got to do what? I in and then do 1 dot dot to 15. We're going to um, let's just make der. We'll do chapter 7 programming project. It's the hardest part, honestly, of the whole thing. I always forget. I gotta remember. Like this. And then that right in that. Okay, then we're gonna say, let's bring this back up one more time. But let's do touch this, and then we'll go ahead and make oh wait. Yeah, and they'll do chapter. What? No, what's going on? Why is it doing that? I think I pressed tab on accident. Touch chapter 7 programming project. Let's do this. No. Right. Slash. Cool. Nice. Okay, that worked. Okay, so now what we're gonna do is just make a make dir chapter. Oh. Okay, and then what we'll go ahead and do is take all these guys. Okay. Nice. Now we're here. Now we up. Let's go. Growing out the neck beard so we can really use the terminal now, huh? Look at that. Watching on my commute. Awesome, dude. Yeah, I do that too. I listen to my stuff back on the commute to get some refreshers. I definitely need it sometimes. Okay, let's go ahead and clear out our top row here. Let's close the exercises and get on into programming projects. Okay. The square2.c program of section 6.3 will fail, usually by printing strange answers if I times I exceeds the maximum int value. Run the program and determine the smallest value of n that can cause failure. Try changing the type of I to short and rerunning the program again. Don't forget to update the conversion specifications in the print call to printf. Then try long. Okay, so let's go ahead and Go to exercise 6. Section 6.3. 6.3. Where is it? Oh, 6.3. All the way back here. There we go. Okay, we're looking for the square 2. There we go. Okay, so we're going to print a table of squares. Using a for statement. Okay, we are going to include the standard io.h. We are going to do int main void, and we are going to open this up. We're going to declare two variables, int I, both of them are integers, I and n. So we know that ints on our machine are probably going to be worth 2 bytes. Because we're on a 64-bit architecture here. So I believe that is what, if I remember correctly. Right, and then a float is 4, or 32 bits. We have 2 bytes or 16 bits for integer values. So then we're going to call a printf and do this program prints a table of squares, and we'll \n here, and then we'll call printf again here and do enter number of entries in the table. And then what we're going to do is call a scanf, and we're going to read the value of an integer into the variable n. And then what we're going to do is do a for loop, and we're going to declare, well, I is already an int, so we just do I, which is equal to 1, or instantiated to 1. We're going to do I while I is less than or equal to n. We're going to loop and do I++. And let's go ahead and open this up and do printf. And we're going to print a integer that is right formatted with 10 minimum spaces of field width. And we're going to do this twice, \n, and then print out I, and the value of I times I, or the power, right, are squared. And then after this for loop, we're going to return 0. Okay. Let's try to compile this. Let's do gcc-o. Let's do here. Oh wait, we need to get into this, sorry. gcc-o programming project. We're going to do exe for this project here. Great, we compiled. Let's do this. Run. 1 times 1 for 16. Great. So that is good. So now what we need to do, according to the problem, is let's go back down. Okay. Determine the smallest value of n that causes failure. Usually printing strange answer if the power of 2 exceeds the maximum value of int. Run the program and determine the smallest value of n that causes failure. Okay, so let's go ahead and make some comments here. I'll say when n is an int, the smallest value that breaks the program is, and then we're going to just figure this out. So what we can do is let's wrap this in a separate function, and we'll call square 2, and we're going to take in a value of int n. Right? And then we'll open this up, and we'll just like leave that like that, okay? And then we'll open this here. And then what we can do is we'll take our square function, bring it above here, our main. We will take our square 2 function and run it. This returns a value. But we're going to do n values. So, and then we need to remove n here because we don't need to declare it there because we already are passing it in here. So what we will, and then we can just remove this, I guess, and then just declare I as an integer in the for loop here. Now, I'm not going to have this return anything. I'll have my main function return a value. This returns what? Null. Can I do that? Doesn't return anything. Is that valid? Or is it void? Yeah, let's say it's void. Doesn't return anything, it just prints. So what we're going to do is we'll call we'll establish int n, and then we'll say for I, or for, yeah, n, which equals to, we'll start off at 0, and then we'll go, sorry, I gotta get back in I've been coding in Python, so I gotta get back in C here. For int n, which is equal to 0 to start, while n is less than or equal to, let's just set a boundary here of, so I times I breaks. So let's just go to like 10, right? Well, no, so that won't work. We might have to go to, we wouldn't want to do 0 because it'll take forever. I mean, it'll only take forever, but we don't want to print that many. We don't need to because it's, well, let's just look here. Let's open up our notes. right? So if we open up our notes, we know that an integer on our 64-bit machine is going to have values up to 2.1 million. So what if we just take the square root of that value? So I'm curious, what if we just do this? What's it called? Standard int.h? Do we say um if we include the standard int.h, we want to what we want to do is we want to get the size of an integer, right? So if we call print, let's just say printf here, and let's call does it print out a number that is a string or a char or like or an integer? I'm not sure. Let's do size of let's say an int, right? Now, I'm not sure if this is gonna work because I don't think it doesn't really know where this came from. So let's look up where we took notes on the size of function. Or it's not a function, it's a it's like a an operator or something. ZU. Okay, so what if I do this and do ZU here? Four, okay. And what happens if I just print a D? What happens then? Unsigned long. So U means unsigned. Decimal. Base 10. Okay, U just means print in decimal base 10. So if I just do U here, as a warning, I think it still would work, right? Yeah. Okay. Now if I do, what does the Z stand for again? With the Z prefix. Forgot. Z on this one? Ah, shoot. Z. Not printf. A Z prefix in size in printf is used for format specifiers to match size underscore t or size underscore t types. Size underscore t is an unsized integer type whose size depends on architecture. Okay. So in our program here, we could do the size of an integer, which is 4 bytes. So we want to do printf to let's do the how do I print? Can you do this? 0b right? Can I do this? I don't know, is this dumb? So give me a value. Maybe not. Can I just insert the value here? What does that do? Oh, it doesn't like that. What if I just do that? 225. Now if I take this value, can I multiply this by 4? Oh, let's go. Okay, so if we have 8 bytes, 1, 2, 3, 4, 5, 6, 7, 8, they're all 1. And so the maximum value we have for a 4 byte is 1020. That makes sense, no? Why would it be 1020? Let's think. So why, if we have 1 byte is, what was the size of that previous one? $255. Okay. And 4 of them is 1020. So then can I solve this? So this was asking me to say Feedback from new change ensures if I times I exceeds the maximum int value. Run the program and determine the smallest int value of n that causes failure. Okay, so when n goes up to a certain value, I times I will no longer read past a certain value. So if we know a size of int holds 4 bytes, so we say this, right? Int has size of, right? And int equals 4 bytes. Right, let me try that one more time so you guys can see. So 1 byte is 255 for maximum answer, or maximum value. It can be held in 1 byte. That doesn't make sense, no? No. That's way low, right? Am I doing this wrong? I'm curious. Let me look up online here and say printing printf byte. Okay, so assume you want the value of a variable of 1 byte. Oh. Trying to think. So why does this print? Let me take this line here and get some more feedback here. I want to see one. Let me see this. That line is valid for 255. It's a binary integer. Sign in. Matches. Standard reports do not include the 0-bit literals. So -1. Okay, so that is the value. Sorry, did I miss it? It's the value of 255. So, it's not 1 byte. Yes, it fits in 1 byte. It's not a byte by itself. Value versus storage is the key distinction. An integer literal with value 255. Int. However many bytes it uses. 4. I can see it is. An int whose numeric value happens to fit in 8 bits. 1 byte equals the size of char. A byte is the smallest addressable unit of memory, is only 6 bits. Okay, so if we true logic for 1 byte is this: unsigned char x equals y prints 255, a literal int, and value holds 255. It prints it when it becomes 1 byte. If we cast it as unsigned char, same as the rule to remember is very important. Bits don't have meaning, types do. As int. So I was trying to see if we could take an integer, figure out its max value, right? Take the square root of that. Well, that's the max value of n that on our system would work for the square 2 function, right? Because, or that would be the 1 max value plus 1. That'd be the plus 1 greater than the max value. That'd be the not the maximum value. That would be the number that broke it, right? So, okay, so then let's just do this. I guess let's just call our function square 2, and let's put in and n is equal to, let's just do like 1,000, I guess, whatever. And then we'll return 0 here. Expected expression. Okay, so maybe you can't declare an int inside that function. Let's just do int n is equal to 1,000. And then what we'll do is we'll throw n into here then. Whoa. Oh. Hold on, let's modify this. So I didn't really need to do this, but whatever. All right, just gonna... Let's see if this works. Okay, so our I values go from 1 to 1,000. We're still getting I times I at 1 million, right? So that's still working because that makes sense. If you look at our program, at our notes here, where were you? Here we go. Our int value is going to go up to 2.15 million. So let's modify this end value to go up to 2,000 here. You probably have to do a little bit greater, right? It should still work here for up to 2 million. Or sorry, for up to 4 million here. Okay, so that's still working here. Up to 4 million in an integer here. So what is this telling us here? So this is able to go up to 4 million here for doing I times I, and which is an integer, right? I mean, we're not saving I. The result, we're just printing it directly, but we're using an integer conversion specifier. Let me bump this up another 1,000. Let's see what happens. It still works at 9 million. Did I read this wrong? Oh, I'm sorry. My bad. 2 billion. I read that wrong. My fault. So let's make this like 10,000. Okay, so that works for 100 million. Oh boy. Let's just keep adding zeros on here. Jeez Louise. Ooh, okay, it definitely broke there, I think. Yeah, okay. Here we go. We're getting somewhere here. So we did a denomination too big, or magnitude too big. Get out of here. What is going on? Okay, so let's go with 100 grand for n. Okay. So we'd be breaking. Okay. If we go to 10,000, I think we did that one, no? No, I think we break in. Okay. That one still works. For up to 100 million. So 20,000 breaks, so let's do 15,000 here. Okay, that looks fine. Oh my gosh, am I doing this right? Hopefully. Okay, that looks right. Gonna go up to 18. Might jump the gun here. It looks somewhat right. But 20,000 doesn't work. But 20,000 does work. I thought it didn't. Okay, so 50,000 is too much. This is probably annoying to watch. Sorry, y'all. 30,000 is not too much. We're narrowing it down here. Okay. 40,000 is not too much, but we're starting to exceed our print statement here. 45,000 loops. Maybe 50,000 does work. What if we're going to determine the smallest value of n that causes failure? Well, will my program literally... It won't like not run. It'll just overflow and print garbage, right? Like, Go back to our notes here, right? So we have an in value, which goes up to 2.15 billion, right? 3, 4, or 100 million. We're at a billion there. 2 billion. Okay, so it's just about to exceed, I think, right? So if we go, we're about to strike gold, and I think we 2.1. Okay, that's one more thousand. Boom. Okay, now we've overflown. Okay, here we go. I think it's right here somewhere. Okay, right here. The largest number, the smallest number of n that causes failure is 46,341. All right. That's not the scope of the problem. The scope is being in. Okay, so I'm going to take this, and let's go ahead in here and say this. Trying to find the bounds of the int on my machine, doing some loops for power 2. Oh, oop. Okay, cool. This was my output for I reaching, what was it, 46340, 46341, and breaking. So the signature of a 32-bit signed int overflow, and your breakpoint at 46,341 is the correct smoking gun. Let's decode it cleanly. What we're testing implicitly. We're testing square integers, I squared, and printing the result as an int. The critical boundary for a 32-bit signed integer, right? We have 2.1, about 15 million. 5 billion, sorry. So now if we look at those squares, that's where it goes to. Okay, so we could have taken this value and just done a square root of it. We would have been able to find that boundary. Okay, so we can take the bounds and take the root to simplify. It's very systems level, I think. To keep x times x within a type, you can take the square root of the type's bound for a signed type. You floor square root the int max. Okay, cool. Nice. Okay, so we're doing this right then. Okay, now we're going to try to change the type of I to a short and run the program again. So let's go up here. We're going to change the type of I to a short. So if should n be an int then? Right, because already if I is a short and n is, they might not even be able to get up to, right? It might not even be able to get up to some value of n potentially before it overflows. So we probably should change the value of n to a short in order for n. Well, I mean, we could determine it pretty easily once the value of I overflows when we start to reach I values that are within this scope, right? So if we did this, let's change the specifier here for, oh boy. H in front of the D, O, or U. Let's see what happens here. Ah, here's something's going on. Okay, hold on. We're going way crazy. Okay, so it's just looping over those boundaries, right? Because it's stuck. That's what was happening. Is we could see that it was kind of going up and down, up and down, up and down, as it was trying to get through up to this point. Interesting. Okay, so let's go back. That's funny. Let's set this to like, well, we know that the short value on our 64-bit machine is going to have up to 32,767. So let's go up to 32,767 here, 68. Let's see what happens. It's stuck. No! We're stuck. He disconnected. Okay, what's going on here? Why are we getting stuck? Because I can't go up to that value, and so then it's going overflowing and going back down potentially. So if we bring this back down to 32,767, like the value of the short that it is, will it stop? No, it still goes infinite. Mm-hmm. Okay, so interesting. Interesting. Um, hmm. Why is this looping forever? Forever and ever. So we're declaring short I, right? Which I can only go up to a value of 32,767. Right? And so when we why does this do that? Hmm. Why does this do that? Is it because we're evaluating a short against a int, and we are then converting the short through implicit conversion to an integer to do the comparison? So do I need to change this to a short and then make this guy go shorty? Shorty. No, we still be glitching. Trying to see here if I can figure it out. We're stuck in an infinite for loop, which is interesting, right? So our value of I is never exceeding because it's overflowing, going negative to the other end of the short spectrum. That sounded bad. Pause. Um, and then I actually never exceeds over n in this case because it's actually equal to. Now, if we set this to less than, I wonder if that'll stop it, but we won't print that last value that causes us to overflow. Yeah. Okay. Here we go. We're onto something. But we overflow quite heavily beyond that because the value of actually I times I exceeds the capability of the short of I, right? So I times I can only go up to this value. So we need to take the square root of that, which obviously we could just do the math for. But if we want to try to just work it through here, so that 32,000, what if we just lower this to like, I don't know, um, do like 11,000. No, sorry. Not 11,000. 1,100. Okay, here we go. Boom, here we go. So 181, 182 is our culprit here. Dun, dun, dun. When n is a short, or when the smallest value that breaks a program is 182. Got him. Okay, now let's go back and get some feedback on that one. N is a short. I found that 182 is our break. Nice. Cool. Okay, good. I'm glad. I'm wanting to work through this kind of slower. I know I'm not moving as fast, and it's going to take me forever to get through this chapter. I know, ooh, annoying, but I'm never gonna have had to use this type of typing before. It's always been abstracted away from me in Python, and I've been coming from non-CS. This stuff is really all new to me, so it's like speaking a whole new language here. So it's like a language within a language. So I'm trying to really get familiar here with bytes, bits, types, how they all interact here with C and whatnot. Okay, nice. So then lastly, we need to try a long. So let's insert a long into here. And I guess let's also make I a long. And then we'll make this a LD, right? Now, is 10 positions going to be enough for a long? Well, a long int at 64. Okay, here we go. Ooh. Holy Moses. That's the billion mark. Trillion. What is that? Quadrillion? 9. What is this number? What is this? Oh my gosh. Okay. So that boy is going to be a problem. I don't think it's going to print in our 10 spaces here. We've got more than 10 spaces, that's for sure. Right, here's 9. This is the 10th. Oh boy. I don't think it was prepared for us to do this problem back in when this book was written, because this book is for C89 and C99, right? And I don't think this had... Did this have 64 capability? You know, I know it did. They gave me this in this book. But it probably didn't expect you to maybe have this. No, maybe, yeah, it did. It was written in, like, not too long ago. Let me catch up on some chats here. Uh, J0V1. Charge us byte. Okay. Yeah. And then my... Okay. Do biochemists program a lot? Not my industry. Nobody at my work programs, but me. sorry. Okay, cool. We're all caught up. All right. Now let's see here. We have a very large number here. So we have this large int value. Now we could take the square root, right? And then floor that by itself. Now that would give us 1. Floor by 1. Okay, right. So limits.h is a header file that's part of the standard library which defines macros represent smallest and largest values of each integer type. Interesting. So let me go actually in here and include limits. Can I go ahead and click on this? No, I can't like go into it. It didn't really give me an example. Interesting. Okay, so let's go ahead and let's do this. So let's try to go like sorry, I keep saying a lot. Let's do the size of a long, right? And this is going to be the number of bytes of a long, okay? We know of a number of bytes. We know the max value of a byte is 255, right? Can we just do that times the value of 255 to find them? But that, we tried that already, right? And that gave us like 1020 for int, which was 4 bytes times 255, which is like 10. Yeah, like 1020. But we know that the maximum value of an integer, am I thinking about this wrong? So you have an integer could be up to 4 bytes. That's for 1 byte. But the thing is it's not times 250 times that, because you're not multiplying bytes continually. The next values get exponentially larger. It's not a linear effect, right? It's exponential. So would we have to do to the power of the number of bytes? Or something like that? I'm curious. Oh. Let's go. Let's think here. So the size of a long, so I'll print f here to ld. Right? That'll give us the number of bytes in a long. Which is 8 bytes. So from that value, how can we determine the max value of a long programmatically, and then identify the max value it wanted us to do it kind of trial and error wise, which we did for the first two examples here. And for these experiments, you can include about the number of bits used. To a machine. Okay, so size of one. I think so. The power 8. Hold on. No, because 250 is the power of. No, I'm sorry. It's a really big number, but I don't think that's the case. Well, because a long can be that both signed and unsigned. So now if we divide that value by 2, that's 7. No, that's not the right answer either. Wait, maybe isn't it 2 to the, I'm trying to remember here, 2 power of, no. This is so hard for me. Okay, so for a long type, we have this huge number here, which can be held within 8 bytes. If we have an integer value of bytes, how can we go from bytes to the maximum value? Well, 8 bytes, we know that there's man. I'm grateful for Python now. Hold on one second. Okay. Okay, so if we have long, which is 8 bytes. Now there's 8 bits and 8 bytes, which is 64. So if we just do this, we don't need to convert this into a long because it's an integer. It gives us back a value, so we'll just do what, ZU. And then if we do this times 8, this will give us 64. Okay, and then what we can do is we'll take this, and we can loop through the value of bytes. Right, let's say that now this returns ZU, which is a decimal value. What does it actually print out of a type? Cast to result Standing no cast is needed, just print the procedure. What's up, no title? We'd be working on a C programming modern approach here. We're doing these programming projects here at the end of the chapter, but they're getting harder and harder here as we've been learning more. So we have a size of a long, which is 8 here. Now if we save this in a value, would I have to save this as an int? Num bits is equal to here. And then if can we print out num bits here and just do if I just do %u here. $64. Okay, cool. So that still works. So then what if we do this? Total, or we'll say long total is equal to 0, and then we say for int I equal to zero, while I is less than or equal to the number of bits, right? We're going to increase I forward, and then what we're going to do, I is going to be our power. But I don't have a power function or operator like I do in Python. Ugh. So you have to, I'd have to write another function to loop over that many times or do another for loop to loop over that many times and compute that power of right. We can use just I caret. Okay, so we say for int j is goes up to 0, while j is less than or equal to I, we're going to increase j forward, and then so we have to say the power is equal, or the subtotal is equal to 0. I guess we'll define this as, it could be pretty large, right? So long subtotal, we're going to take subtotal plus equals to the values of hold on, I just got lost. So we're having I is equal to 0, and while I is less than or equal to the number of bits, we're going to increase I forward. So we're going to go from 0 to 64. but we don't want to do that actually, because we're going to start off on the first bit and go up to the include the 64th bit, right? So up to 1 to the less than or equal to the number of bits. Then we're going to compute a subtotal for this bit. So we're on the first bit, which j is 0. So we're going to take the value of I to the power of, oh god, why is this getting so difficult? I probably should write it down somewhere. Let's see, pull up a whiteboard. Base 2 to the powers. Okay, so we do um, 2 times j. So it'd be 0 times 2, 0. But no. Do we start off on 0 powers? It'd just be 1. But if I multiply by 0, that would just give me 0 for the 0. Right, so 2 to the power of 0 just gives me 1. 2 to the power of 1 gives me 2. 2 to the power of 2 gives me 4. Right, so if I do 2 times j here in this inner loop, then the subtotal will go from 0 to 2 6. I don't know. Why am I blanking so bad here? I think because I'm trying to combine too much stuff at once. I'm trying to figure out bits and stuff and then powers. Okay. So we have total is equal to 0 and int I is equal to 1. We're going to loop over all the bits. Okay, we have a base 2. Now normally I would just take 2 to the power of I and then add that to the total. But I can't do that because C doesn't have a power operator. So what I need to do is for every bit, I need to take the total and update it by the value of the next power. Now, I'm wondering if we could kind of memoize this, whatever, and take the total in our subtotal computation and then just add subtotal, update subtotal by, yeah, so can we just do actually, if we have a running total of all the powers so far, can we not just take the total we have, the running total, and just multiply that by the next value of I, right? So maybe I don't even need to do this. So if I say we start off at 0, total plus equals 2 I oh my, the current value of total. Total 0. 0 in the first pass. Maybe 1. So maybe I should set total to be 1 at the start. And I have an update by 0. The total goes to 1. 1 times 1 is 1. We go to 2. Total goes up 2. Three times 2 is 4. Total goes to 4. Yeah, right? So if I print here, just print F here for %d, a long integer for total. Let's see what that gives us. Man, long time working on this problem. I'm trolling. Sorry, y'all. Okay, just a bunch of 0. So it's 0. Total never updates. Oh, it does. It just prints consecutively, and it doesn't ever update. Right. So the total starts off at 0. 0 multiply plus equal I, which is 1, times total, which is 0, so 0. I goes up. I is now 2. Well, total always stays 0, that's why. So I need to set total equal to 1 at the start, which is what I forgot to do earlier. So now that prints me 2, 6, 24, 120. Okay, so not quite. Then it starts to overflow the long. Because, right, the difference between 2 times 2 times 2 versus 2 times 2 times 2 times 2 is just another multiple of 2 added on to the previous 2 times 2 times 2, right? So we don't want to multiply this by I times the total. We would just want to do it the number of times of total by total, right? So by itself against no, not times total though, because we don't want to do 24 times 24. We need to keep the original value. Of our, oh my gosh, why am I trolling? Brain's hurting here. Doing math on a Sunday. So we're going to loop over each bit. For each bit, we're going to need to take a power, 2 to the power of the bit of the loop we're on. But we can't do that. So we don't want to multiply the total by itself. We want to multiply it by our base value, right? Which in this case for binary would be 2. So total would increase by, for every round, we want to increase value of total by what? Multiply equal by 2. I'll update the totals. 248. Okay, here we go. Let me overflow here. Perfect. So then let me print percent D this, and I'll print I here. So on 63 for I, so power of 63, it overflows it. So what is that telling us exactly? Is that, so we're increasing our value of I, which is the bit we're on. So on the 63rd bit, we overflow computing a power for a long integer. I computed the number of bits in a long int by size of long and times 8, which equals to 64. I loop over 1 to 64 and compute a power using total equal 1 and total multiply equal 2 for every bit. I overflow on bit 63 in this output. But you're seeing exactly the expected behavior of a signed 64-bit long on 2's complement machine. Let's walk through it cleanly and tie it directly to your output. What type you're actually computing? You did size of long times 8 is equals to 64. We do a total is equal to 1. and total multiplied by 2 respectively. Total is a signed long. So on most 64-bit systems, a long equals to signed 64 bits with a range of negative 2 to the power of 63 to the 2 to the power of 63 minus 1. (63 minus 1). Why it breaks at bit 63. Your output is powers of 2. 2 to the power of 62 gives you to this. 2 to the power of 63 gives you to this. But 2 to the power of 63 does not fit into a signed 64-bit integer. Yeah, it's one value greater. Okay. Which is, yeah, okay. Which is 2 to the power of 63 less than 1. So when you compute this for 2 to the power of 62, why is it 63 though? Why? So we have a long integer, which is just a very large number that's represented using bits, and it's just a way to condense values down using base 2, right, rather than base 10. And so, or it's a way to not condense down rather, but to model values as ones or zeros. Right, so that's beside the point. I'm going to go back that far. So we have 64 bits for a long int is what we're using, which is 8 bytes. The maximum value a long integer can hold is this 807. Now, if we compute, oh, got you. Okay. So because the magnitude of the bits from like 50 plus are so big, pause, it's likely that the power still fits in the same type long. Oh. But when we get to the 63rd bit, computing a power on, or a POW2 on that bit causes us to overflow. So every number lower cleared the type bounds. Every power of 2 up through 2 to the power of 62 fits inside a 64-bit long. 2 to the power of 63 does not. It overflows because that bit is reserved for the sign. Oh, that's right. Oh, I completely forgot about the sign bits. That's why we can't use the 64th bit. Ah! Aha! Okay, now that clicked. Okay, so I was like, why are we not being able to go up to the maximum capability of the 63rd? Why are we having to end on the 62 and overflowing on 63? Well, this is a signed value. So the 64th bit is reserved for the sign. Uh. Okay. So we the maximum value is actually created on the 63rd bit. Okay. So the max value is actually act, actually created on the 63rd bit because the 64th is the sign bit in the signed long int. And the magnitude is not large enough to hold the 62nd squared. For a 64-bit signed long, there's total 64 bits. Bits indices are 0 to 63. Okay, so so it's 0 indices for bits too. Just like they are in arrays, probably, yeah. So signed bit 63, the highest bit. So I was just off by 1 because it's 0 index, sorry. Yeah, sorry. Off by 1 if 0 index. Cool. So the 64-bit, nice. Okay, sweet. That's helpful to know here. So, the maximum value we can make is this guy here. So, this is the max value made on bit 62. Right. So 2 to the power of 62 is the largest single power of 2 that can represent any 64-bit long without touching the sign bit. Okay. So then what would the solution for this answer be? Smallest value of n to cause the failure. Well, n in this case, sorry, we're going back here. N is the value that I goes up to for computing these powers. So is it not... See, that's the value, right? So it'd be the square root of that value. So the max int, so the max number that, or so the smallest number that causes overflow is the square root of that. What? Smallest number that causes overflow when double repeatedly is not the square root of 2 to the power. Depends on operation you're doing. Here's when you're looking at fit. 2 to the power 63 less than 1. Oh, we are squaring the values. Oh, maybe did I kind of go on a tangent here? I am computing the square up to a certain n value to determine overflow. You're doing n times n repeatedly to see what the exceeded bounds of the 64-bit long. N squared is less than or equal to long max. Does this do caret in later versions of C? Let me look it up. Is caret allowed in C? Like later versions? No. It's the XOR logic. Yeah, okay. This guy here. How relates to your early doubling discussion? Each time the threshold, at the threshold to the power of 62, we overflow it to the power of 63. When squaring the threshold is roughly 3 times 8, or 3 times 10, sorry, the power of 9. We overflow at this value. Okay, so let me back this up, bag it up. We didn't really want to do that then. Let me just go here. Go back to what we had before for the short example. Back it up. Here we go. It's coming up. There we go. There we go. Nice. Okay, so when n is a long, the smallest value that breaks the program, it's actually this thing here, 303,7,499. Interesting. Okay, so we definitely needed to add more field width parameter. Oh, that's minimum, right? Minimum of 10. So it would have kept going, actually. So if I change this to long, I go this to long as well, and this to long as well, and then I take this value, I stick it here. Let's try it. Oop. Whoops. Oh, sorry. Is it infinite, or is it just taking forever? It might just need to take a long time because it's a really big number, right? It goes up to 9, right? We gotta wait for it to get to 9. Ooh, let's we can short circuit this a little bit, I think, right? We can do, let's go up to here, let's do this there, but put 400. Oop. Okay, there we go. Then if I go up to 1, what? Let me print spacing. Oh, there we go. Okay, sorry, I wasn't reading it correctly. So this overflows, but it doesn't throw an error. Does it overflow? 39223372036 or 039. Oh, 030. Okay, let's go up 1. Hold on, let's go up. Oh, less than or equal to, and let's see if that'll. Yeah, then it breaks here. Okay, perfect. So the largest value, sorry, is 500 that it breaks on. That's the one that it breaks on. Or the smallest one, okay. Sheesh, okay, sorry you guys, that one took a long time. I was working through that one for the whole entire time we're supposed to be getting through this. But I just needed it. I would just to kind of brute force through some examples to get more familiarity with binary and with what's going on with these integer types and their maximum and minimum values and overflow. So this is, yeah, I don't really mind. Let's see here. Let's get caught up on some chats. Hey AJ. Okay, cool. Let's keep rolling. All right. Nice. Okay, so let's go here and we'll make an assumption. So based on this information, my machine, a 2020 3? It's crazy. Pro 64-bit. It's a 64-bit chip. Is that the correct assumption here? Okay. Man, long long first problem. Holy crap, that was one for the record. I feel kind of bad, honestly, but I don't really feel bad either because it is what it is. We're learning. I learned a lot there, and I got a lot of good practice. So whatever. I don't really care. It's not like we got a boss here that's telling us we got to move on or anything. Okay, number two, modify the square2.c program from section 6.3 so that it pauses after every 24 squares and displays the following message. Press enter to continue. After displaying the message, the program should get use char to read a character. Get char won't allow the program to continue unless the user presses the enter key. Oh, this one's kind of fun. Okay, let's go take a peek at this guy and grab our square function. Let's include the standard IU.h. Let's throw this guy in here. We'll have this return an int. We'll change this to main. This will go void. This has int I and n. This goes printf. This goes scanf, where we read into the value of n. And then we're going to do for int I equals to, was it 0? I think it was 1. Yeah, I think it was 1. Okay. And then we're going to number down. It's into the Mac 0. Okay, so let's go into here. And boom. Okay. Oh, I think we have to say something here. Sorry. My bad. Enter a number. Whoops. Oh no, we'll leave that like that. Try it again. Okay, enter a number. You guys can't really see the that really well. Let me bring it over here. Okay. Let's try it again. Enter a number 10. Cool. So it's still working appropriately. Now what we're going to do is modify this to pause after every 24 squares. Okay. This is not that bad. So we'll say if I mod 24 is equal to 0, we're going to display the message press enter to continue, print f. Well, we probably have to do this afterwards, I would assume. So we're going to print f and say press enter to continue, and then we will and that'll be fine. And then what we're going to do is call, let me define a variable in this scope for the value that they're going to press, right? So we just need to do, this is going to be an integer, I guess, but it will also be technically a char, but I think we could use either, but I'll just stay char. Um, Now I don't think I want to use get char because it might give me back the backslash and then the carriage return, right? And I want to get back both of them in one go. So we'll say char um, temp or whatever, I guess. And then we'll read into scanf into a %C, I think, right? I've never done it before. We'll find out. Into temp, the value here, I guess we're going to say we probably need like a while loop to continue doing this, right? So we need to continue looping if temp is equal to, what's the, let me look up an ASCII table. Ta-da. So the carriage return is decimal value 13. So if this equals to 13, we're going to continue the loop. We're going to break out of this while loop. If it doesn't, we're going to continue and ask this question again and again and again and again. Something like that. Right? Let's find out. We're going to print the number. If the value we're on is a divisor of 24, or is a multiple of 24, then we're going to loop until the user enters in the carriage return value of 13 into the scanf. Let's find out, dude. No time like the present. We compiled. I hit it twice. Oh, why did it print twice? Oh no. Why did it print twice? And that doesn't work. 13 doesn't work either. Oh gosh. Oh no. Saya, we've broken it. It's broken. I'll move this down here. Okay, what's going on here? First off, we printed this twice. If it's not 13, we break. How can I identify the carriage return? Let me try that one more time. No, we're printing it twice. We're getting to the 24 though, which is good. We're printing this twice. Print, enter to continue. We scan. What? We define a char. We print the prompt. Press enter to continue. We scan the value of whatever we entered into the char temp. If the temp value ends up equaling 13, do I need to cast the char? I don't think I need to cast like an into this temp value. Yeah, that's what I was trying to do, is the character term. What's the watch name? Oh, dude, it's a cheap like $10 watch from. This is like what all it's just a $10 watch from Walmart. It's a Casio. It's like the most like slept on watch of all time, but it's like super popular, but it's not at the same time. Honestly, I think it's like the best bang for your buck cheap watch. Like it's got a lot of cool. It's just cool. They got like a black face on them too, and they got other types of faces that you can get. Which I don't know. I like these watches a lot. They're just cheap, like $20 watches, but they have a lot of like style to them. So I don't know. I've had this since like freshman year of college. It's been going ever since. Mac may use a new line. Okay, let's check. Well, I'm wondering why are we getting this output twice? Doesn't I don't get that. Let's look the new line feed, new line. Character turn. Anybody have any idea why we're getting this print twice? Why is that printing twice? For some reason. Why is it printing? I get why it would be printing again if we got it wrong. But why is it printing twice initially? Like if I keep going, if I press T, press enter, it prints out twice every single time. except when I press enter once. Do you think it's because it's reading the T and then the scanf? The character, like it's doing that comparison just really fast. Saying, okay, it's saving char temp. It's reading the T first, seeing it's not there. But no, it should be reading the entire string, right? What if I call print... well, let's move this down to printf here. Let's insert into here the value in decimal of temp. Okay. Whoa. So what's happening is it's hitting the if statement. It's printing. It scans F and reads in, I think that the enter that I pressed to run this prompt. What? So strange. So they're saying, tell me to move my printf to after the scanf. Now, okay, so it's getting a value of temp before I even watch. I think, no? Not print, Python. Ah, come on. Yeah, see, it's printing out a value. Okay, so it's leaving behind. That first scanf is picking up the 50 and leaving behind the return that I did to enter the 50. And then scanf is taking and getting that return and saving it in temp. Okay, so then okay, and in this case on Mac, my new line character, my carriage return is actually 10. It's not 13. Right? Okay. So then we scan F. It didn't tell us about clearing any buffer, any input buffer, right? It didn't tell us about that. So do you just use an arbitrary scanf to clear input buffer? Is that what you do? Do you just call a scanf to any? This is tough, dude. Okay, that's a good idea. No title. It does? Oh, bruh. Come on. I didn't even read it. My bad. After displaying the message, the program should use get char to read a character. Oh. It's get char, not scanf. Okay, my bad. Sorry, y'all. Okay, so we get char temp. We are going to call press enter to continue. Now, what I can do is put that here actually. I don't need to reprompt every single time. And what I can do is get char. Of, and this will return back char temp is equal to this. And then let me printf to the temp variable here and see if that works. Okay, yeah, so that's working. But what's happening is it's reading the enter that I pressed within the scanf here. So I think I'm going to allow for spacing at the end of this. No, because it takes spacing. Okay, so the scanf, when I give the number of 50 to be read into n, and I press enter, the scanf is reading 50, getting to the backslash n or backslash carriage return, whatever, and stopping and leaving that in the input field. And then my get char is pulling that down already. So I need to allow for the scanf to have white space um okay, so the so can I let me go back to my notes on get char. Where to go? Scanf does not skip white space before reading a character. Reads one character, returns the int value, does not skip white space. Skip white space leading in front of the character, but not the end of the character. So should I just use another scanf to clear the field, or how can I? What do you guys think? Should I be using another scanf? Or, oh, should I be saying get char here for this one? Or using scanf like I had before? No, it only wants to get char afterwards. So I'll say while char temp equals to get char, that does not equal to 10. We're going to loop, right? Else it's 10, we break. We prompt this message. Right.
You're not that guy, Paul. Trust me. You're not
Thanks
that
for the
guy.
follow.
Okay.
Kay, Cody. Appreciate
Absolutely.
you. Thank you, Kay. So while char temp is equal to get char, and that's not equal to 10. What was that? What was that? Twitch be throwing me some funky stuff. What was that? I'm not sure. Press enter to continue. Now the thing is it's gonna pick up that scanf. Can I not do that? Ah. Okay, so it's just a warning for wanting to use parentheses around the assignment. And then can I assign a char here within the actual scope of the variable? Maybe not. I compiled. Maybe what we'll do is we'll do a do the following while, right? Do the following while that. We want to initially do that action. Is it like this? Do that and then you open it up? Or no, it might be like this. Do this while that. And then we'll be to this thing here. Ugh. Okay, that works, but we just need to now figure out why does the scanf read in? So what is the typical way you're supposed to do this then? I got it to where I am reading mod 24 for I and waiting to continue, but the enter used to enter a number is being caught by get char. You called this reads an integer from input but leaves the new line in the input buffer. So after typing the number and pressing enter, the buffer contains this. Then when you reach this statement, the first get char reads the leftover new line immediately, so you can actually pause to enter. You need to clear the leftover with just an arbitrary scanf. Consume the new line right after the scanf. Then your get char pause inside your loop will work correctly. Use get char once before the loop. And save it in N. Why would we save it in N? Oh, sorry, we're not. We're just arbitrarily getting it and just disregarding it. So you could call it once right here on line 10. So you can call get char here. This will consume the leftover new line char in the input buffer. Interesting. I'm learning a lot here regarding how this is like working. Getting just a lot of practice. So now if we run this, stops on 24, enter, stops on 48, enter, and it gives us the rest. Cool. That's problem 2 there. Nice. So can you also say this? Can you just also say while scanf, or sorry, get char is not equal to, do you just say like \n here in this? You print this statement. So get char returns the number, right? So we're comparing the number to the integer, or the number to the actual char star, it looks like. So I don't think that's gonna work. Yeah, I'm seeing, okay. So then, what did it say for that? It said you can say, well, get char is not equal to quote. Is it singular quotes for the character? Sorry. I think so. Ah, yeah. Now it's not actually printing this. So I guess we'll open it, take this value, throw it in there. Now does that work? No, it's not actually printing that either. Oh, well, it does equal to that. So we want to just print it, and then use the get char after we print it. So if I do 7, that won't work. Enter. There we go. Awesome. Oh, 7 did work because I pressed enter on 7. Like I did 7 enter. Oh. Weird. Right, that's peculiar. So do 50. Right, if I say 7 enter, it goes up because I pressed enter. Huh. Right, so this works, but if you type like 7 enter, it will still move on. It consumes everything in the input buffer until the next new line. Type 7 and then enter. Your loop sees 7 first, discards, and then stops the new line, effectively letting the program continue immediately. Wait for a single enter press. If you only want to continue when the user presses enter, ignoring other characters, you can call a single get char, ignore the buffer afterwards. Well, the characters we call single get char. Well, the character does not equal to this. We continually get char. Huh. Because this is what I had before. Right, this do while loop. If I do 7 and enter, yeah, it does some weird stuff. Press enter to continue. Call get char. Call get char here. Actually, C is equal to get char, which is an int. EOF. So this is what I was trying to do for this like entire function here. And see here goes a couple of small issues we're piloting. For the biology, let's say something like this. Get char consume the leftover for int I. We're going to continue to enter get char. No way this works. What? With no loop? No way. Press enter to continue. Get char. Waits for enter. What? Yeah, no way. And it prints out Well, I guess you can't with just how getchar works. Yeah, right. This seems kind of like a hack, though. Like it's like I guess with how it's kind of clever. I know, right, John? Like if you think about it, the getchar, in order to actually receive the input, the user has to enter into the standard out. So the user has to press the enter key to be the final whatever. So I guess it is like a clever way of thinking about it by just how data is entered, because they have to press enter to finalize, or sorry, standard in, my bad. They have to press enter to finalize the input into standard in. And so by getting the char on any new char pressed means that you pressed enter no matter what. This feels kind of hacky, but smartish, I guess, because the user has to press enter in the standard in to enter a value, whether it is quote 7 enter 888888 enter, or space 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 enter. The enter is read, or the whole thing is consumed, so it, and so yeah, there is an enter.
You're not that guy, pal. Trust me. You're not that guy. Okay.
But
yeah, you? Absolutely.
What if that? What if? But yeah, you got the intuition spot on. You're doing is basically treating the new line as the true signal. Anything that user types before pressing enter is just extra noise that gets swallowed. That's why it feels kind of hacky. You're not parsing the input carefully. You're relying on the enter key to flush the buffer. The scanf reads the number of lines in the new line buffer. The first get char eats the leftover new line. Then every 24 lines, char waits for the new line. If the user types 7 plus enter, the buffer gets 7 \n. Get char reads 7 or whatever character, then the while loop consumes the \n. The program resumes because the new line was eventually read in the property of get char. So get char has an internal while loop. Get char really does is this. Get char is an input buffer. What it feels like. And why'd you say this? I don't know, GPT's kind of hacking me here. Why did you say this? I should clarify the wording because it's misleading. In your original code, we did this. First get char reads the 7, and leaves that \n in the buffer. Well, it should, like, honestly, it should kind of expect like these kinds of questions if it's asking us these kinds of questions. After displaying a message, the program should use getchar to read a character. Getchar won't allow the program to continue until the user presses the enter key. So yeah, it kind of is wanting us to use this based on the property of getchar itself. So the question is wanting us to use the property of get char itself to infer the enter or whatever. Okay. Mike, read the question maybe. Probably would help a little bit. Okay, well, that's interesting. I'm kind of used to like Python, how you literally. I think that's why I'm like a little bit struggling with the thinking of this because, like before, why is it doing this? Before or with Python, I can literally just detect if that input, right, is equal to whatever it is with like a strip or whatever or whatnot, and we haven't kind of learned that yet within this book. So whatever. Okay, cool, you guys. Well, that sucks. We only got 2 values done here, 2 questions. Oh my gosh, dude, this is gonna take me forever. Someone warned me that once you start getting towards chapter 9, people start tapping out because it starts taking a while to get through the chapters. Because I mean, we could move faster on the questions, but I'm really being thorough with trying to understand what's going on, and like understanding, okay, why we're getting certain errors, what properties, and I am learning a lot. So no, I've never compared my solutions. No, I've only just gotten my solutions and moved on. I get feedback from the Givity though, but sometimes it can be kind of finicky. Cool. Yeah, that's right. No title. So we're only gonna get better by putting in this time and working through these examples and really understanding what's going on. So, if you guys are enjoying the way things kind of are. I appreciate you guys being patient with me as I work through these problems and kind of go to understand them. I'm really trying to be thorough here with our understanding and taking a serious approach like I did with Python, and that's why I think we were able to move through Python, or not all the way through. There's still a lot more to learn, but move through the basics of Python fairly quickly and build some projects because we were able to put in that time and effort at the beginning to build a solid foundation. We weren't having to go back and look things up and reference a bunch of beginner stuff because we really took the time ahead of time in our Fluent Python, or in our Python crash course, Fluent Python, CS50P, all that jazz. Cool. Um, okay, I think I'm gonna call it here though for today though. Sorry, you guys. We finished 2 programming project problems in 2 hours and 45 minutes. Oh my gosh. Yeah, I'm doomed for coding interviews, you guys. I can't work. I'm just like I live in a permanent state of just chill. I live in this permanent state of chill, where yeah, I can move fast like on like physical stuff and chemistry and things like that. But when it comes to coding, and I like to really like I don't know, I just move through it how I move, and I've gotten into the habit of kind of being the snail here. Let me tell you, when I did that one coding interview a couple of months back, um, I ran out of time. It was like I kind of shot myself in the foot with my prep because I mean in our learning where we've been kind of really stretching the times here, and so I don't really have a sense of urgency with some of this stuff, which I don't really care about at the end of the day, but that's what the people want for the interviews.
Right.
All right, you guys, thanks so much for being here. I appreciate you guys.
You're not that guy, pal. Trust me. You're not that
Oh,
guy.
Power Prover, did you read this
Yeah,
book too?
Absolutely.
Thanks so much for the follow, PK Devil. Thank you, dude. I appreciate it. You're awesome. Thanks so much for joining me. I think Power Prover, thank you so much for the follow on Twitch. We got a lot of people coming in today. I really appreciate you guys being here. You're only moving slow because it's new. Yeah, we're trying. Thank you guys for hyping me up. You guys are keeping me so good, patting me on the back and keeping me giving me some good support here. I appreciate you guys. I sometimes can get a little bit in my head because there is a little bit of an entertainment value to the stream. I'm not like super funny or whatnot. So like if I'm not moving super quick through stuff, sometimes I feel that maybe like the entertainment value could lack or whatnot. But honestly, I think I need to remind myself often that you guys are here to really kind of get into the nitty gritty and learn like this stuff with me, like to its core. Like we didn't make a channel. Our channel is really not known for just doing a little spark note and doing quick passovers of stuff. So if you guys, I don't know, that's kind of audience I've tailored so far. So yeah, coding interviews suck for professionals too. Yeah, dude. I still have nightmares to that one I did back a couple months ago. It's the only one I've ever done, and I did not do too good. But it's whatever. I don't know. I think it hurts so bad because the market is so bad that I felt like it was like my one shot. It was like the door finally opened and then just landed right in my face. Oh no! It's like finally I got an opportunity. I think that's why like there's so much pressure with the interview too, is because you're like, oh, I finally got a shot. So I finally, and then it just slams in your face. Coding interviews put me off coding. Yeah, honestly, that's a very fair take. I have been very reluctant to send my resume out to places because I have mainly, well, one, I'm not getting much hit back, so it kind of seems very pointless. Two, um, I have just kind of honestly, I'm a little bit scared of the interview. Like I'm not afraid to admit, like I'm very transparent with you guys, very honest from my point of view as a learner coming from this as a 26, 27 year old, almost 27, um, like just trying to learn this from scratch in his room after work, just like as any normal guy would really. At least that's how I try to think about it. I don't think I'm like that much smarter than the average person or whatever. I just maybe work a little bit harder and put in a little more time, and that's kind of what sets it apart. But I really don't think I'm that much more intelligent or anything. It's really just I think comes down to the sheer will of wanting to learn. Um, but yeah, dude, let me tell you, after that experience, I was really kind of deterred from wanting to continue down corporate software development because I just really didn't like if that's kind of like the vibe or the environment of it. I don't know, dude. Like, there's just something really kind of off-putting about having to potentially go through like a degree course, especially if you are a software engineer, like by actual education, formal education, like to have to go through a degree course and obtain this credential and have a resume with projects and whatnot, but then still have to prove through some like menial like brain teaser is like so troll in my opinion, dude. It just seems so like goofy. Like I really wonder like how many candidates, like good candidates, were potentially passed up because they didn't solve a brain teaser. Like I now I'm not saying that if I applied some more places that I would get another shot, but like I'm really like not really wanting to because it really sucked the fun right out of like doing this. Like for the next couple of days, I didn't even want to stream because I was pretty like just distraught over just looking stupid in front of I guess experienced people that had the yes or no badge of approval for whether I beat the Elite Four. It's like what the heck? How long have you been doing this book for? I purchased the physical copy. Oh, nice, Trevor. That's really awesome. I've actually been really thinking about maybe picking up a physical copy of this one. And there's another book that I've been reading. Let me see if I can try to find it here. Um, there's another book that I've been reading called. I've been reading it offline. It's been actually really helpful in tying together some of this stuff and getting more into computers and how that it works with the CPU. But it's called what is it called, dude? It's computer something. A programmer's perspective. Is it computer architecture? Computer architecture, a programmer's perspective. Computer Systems: A Programmer's Perspective, third edition. I've been reading this one offline. I'm on chapter 2, so I'm not too far. It is pretty like there's a lot of information. It's very, very like it's not a very hard read. There's not like a lot of big words or whatnot, but it's just like every sentence is a new fact or something, like a new definition, new fact or something about computers. So if you don't have any experience with physical hardware and how it actually interacts with the software, then it can be a little bit of a slow burn. But what I've often found myself going over a couple of paragraphs, being like, "What the H," and then having to go back and read a couple of paragraphs again because, but you know, it is what it is. You stay focused not to move fast. It's the content. Yeah, so I've been reading Computer Systems: A Programmer's Perspective, and that, in chapter one introduced kind of just general basics about, it uses C and it references C in the book, so it really is good for pairing with this one, in my opinion. The first chapter already kind of talked about ASCII values that we were introduced to in these couple of chapters and talked about how that interacts with the processor. It really described bits and bytes kind of more in detail for how and then this book kind of takes that information and relates it to types in C, right? So it's really good for pairing to learn about the fundamentals of like binary and computers and then how that builds into C here. So I've been really enjoying actually kind of going back and forth with those two books. So I'm going to throw that book actually in my Discord, link down below for free. I'm going to make a channel in my Discord, and throw that one in there for you guys to reference. AJ, he's been telling us that one's goated, yeah. um, uh, Coding, how long have you been doing this book? Well, we've only been doing this book. You can go back on the channel and look back to when we did the first read, but probably a month and a half, maybe. It's a pretty dense book. We've been doing all the exercises and programming practice projects. So we've been moving as fast as we can, but relatively quick, I think, for the amount of content we've been covering. And I've been uploading videos to the channel, having to go back and edit and stuff. Worth bearing in mind that not all computers are ASCII. Yeah. Sometimes a YouTube video can help visualize the concepts. Most have it now as rudimentary level, but I've worked on some that didn't. Some memory made sense to me. Nice. The education helps you a lot, but it still doesn't prepare you for lead code. I learned the basics and make projects before trying lead code. I've already solved about 200 lead code problems. No, not that many. Is it that many? Maybe 100. Let's see here. Is it? There's no way I did 200. Trolling. How many did I do? Oh, 118. Yeah, no, 200. Get out of here. 118. Mostly easies. So we've got some good experience with our Fluent Python and DSA in Python. That we read DSA in Python, about half of it, and we read about half of Fluent Python. And with those, we were able to kind of work through and get some understanding into DSA and get some practice with that and start busting out some lead codes. But yeah, we're nothing special here. All right, you guys. If you guys enjoyed the stream tonight, could you please leave a like? It'd mean so much to me. We streamed for almost 3 hours today, going over some slow approach, going over some of these programming practice problems from the end of chapter 7 of C Programming: A Modern Approach, second edition by K.N. King. I got a copy of this in my Discord link down below. You can also find copies just online by a quick search. It's a great book so far, and I've been really enjoying it. Thanks so much for bearing with me as we read it. And I uploaded today a Python crash course try yourself solution. So make sure to go check that out if you haven't. I recorded the next like 3 or so I'm going to be uploading those over the course of this week as well. Tomorrow, we're probably going to either jump back into this or continue on with our Pocket Farm app. So for those that are still here that are new, Let me show you guys my Pocket Farm app really quickly. I'll just show you the front end. Let me go ahead and actually, well, hold on, I'll push this up real quick. We'll say continue, or we'll say start at chapter 7 programming. Push. Okay. Okay, cool. So that's pushed up to the hub if you guys want to check that out. But this is my Pocket Farm app that we've been building live on the channel every so often for the past like 2 or so weeks. We've got a lot of good progress on it so far. Let me go ahead and just CD into our client here, and then CD into Pocket Farm. Client slash Pocket Farm app, and let's go npm run dev here, and we can go into this guy and I'll show you. So this is our Pocket Farm app so far. It's pretty cool. Pocket Farm is going to be a cool little ability, a place to kind of transact your various movements through your home garden. So I like to garden. I like, growing vegetables and various things, when I have the ability on my porch and whatnot. And I think it'd be fun to be able to track like your watering schedules, fertilizers, whatever kind of tracking statistics you might like to in these overall kind of events. And then you can have those events linked to your crop, and then you can have multiple crops. And in these events, you could take pictures and kind of track a life cycle of the entire home garden. So basically, your pocket farm. So we have this cool kind of character here. His name's Pothead. It's a fun little pun. I thought it was cute. To be a kind of like our guide and mascot through the system here. So Pocket Farm is this is just the hero page where you can create an account or be a returning farmer and sign in. You have the ability, right, to create crops. You can add crops to your Pocket Farm and watch them grow. With Pocket Farm, organizing your garden has never been easier. You can track crop statistics, create customized crop events to measure, track crop of aspects and growth, height, logs, humidity, harvest dates, whatever. You can eventually capture and share your crops with your friends on maybe like a public board. So I think it'd be really cool to have the ability to follow other farmers and share your crops to a potential board, to a feed, or just maybe share with a direct link to various other places. But that one will probably come in time as we work on just core functionality of creating and tracking our crops and statistics. So this is our hero page we wrote up. We have this guy. Shout out to, I'm gonna have an artist kind of really make this real, but shout out Gemini for this mock-up right now of our little character kind of in the Adventure Time kind of stylish themes-ish. I like that. But I'm gonna kind of reach out to an artist and have them vectorize this, or I might do it myself if I have enough time. But then we have a sign-in page or a sign-up page where you can sign up. Let's get growing. Has cool features for doing all this. Has the password hide and show. We implemented that, and then you can go back. You can also sign up in, right? You're returning back in. Your crops missed you, and you can have the kind of same sign in here, or you can go sign up versus sign in right on this. And then we were working on currently is our dashboard page, which is here. So last time a couple days ago, we built this little header section for our actual profile, which is really cool. I think it looks really nice. It's really clean. We've got a cool little circular kind of for a profile pic. We've got your title with your badge indicating versus free, maybe versus premium for every membership tier, if we decide to put that in. Your username, your member join date, and then a little about me section that you can edit or whatnot, which is some warm text in there. And then we have this little table here, which you'll be able to add your crops to eventually once I figure out that functionality, which will be quite nice. Hopefully, let me go and read this. There we go. And then you have like more information. So this will take you to the crop page for that specific crop, and you can see everything. You could share it with whatever, or you could delete it out. So trying to work through this little by little, but yeah. anyways, I appreciate you guys being here and hanging out. So we'll either work on this tomorrow and keep going on Pocket Farm and really trying to develop our first, fully functional. We have a couple of web apps, SpectroSim and ChromaPlot, that you can get access to via my website, michaeldeming.com, or you can look them up, spectrosim.com or chromaplot.com. Um, but this will be like our first kind of like real full database account kind of web app thing rather than just maybe like a simulating thing. So a lot of work going into this. I've been researching all weekend about database stuff. So I actually downloaded Docker today to help containerize a Postgres environment for development. So what that means is that Postgres is a way to interact with SQL, from my understanding, via a server like extension, right? So you can have your database live on a server with Postgres, and then use commits via calls to that server or whatnot. Now we don't have a server we're paying for right now in this development stage. So what we can do is use Docker to make a container on our system here on my MacBook to basically set up a kind of a server environment for Postgres to kind of reside, and then I can develop on top of that, um, and then yeah, so that's kind of how I'm thinking about it. If you guys have any experience with that, please chat with me in the Discord link down below. I'm still learning a lot about database stuff. I've done a little bit with SQLite. I'm trying to get better with database stuff because data is becoming the most valuable thing in the world. Um, and so I think if you know database stuff going forward, you probably have a good shot at being successful in the future, especially if you're really good at it. So I think it's really important. That's my hunch. Anywho, but um, yeah, so if you have any experience with Docker, Postgres, and how to set that up, I've also was thinking about like obfuscation. I don't know if that's the right word, but maybe like repository layering of the database. So we don't want our API calls to really write and open up connections to the database, right? That's taboo. So what we probably would want is some sort of layers, like these layers, right? A layer that would establish the connections to the database and would determine, based on which environment variable, which database we're connecting to, a local Dockerized Postgres container or a actual server-based connection for a real whatever. Um, now we we and then maybe I'll have a layer above that that actually runs the calls for doing the SQL command queries, right? And then the layer above that is the API layer. So I don't really have to go through my API and edit all of my endpoints for different queries or whatnot, or different flags for whichever system I'm in. I can just kind of go down to that layer and change whichever sub aspect I need to, if that makes sense. I've been really trying to wrap my head around just like software design of how this is supposed to be approached. I really don't know. Um, but yeah, I'm not sure. So anywho, if you guys have experience with that in the Discord, chat with me and everybody else. We've been kind of talking about it for the past couple of days. Um, have you looked at the three-tier model? Is that kind of what I described? I think that's kind of what I just described, no? Like a low tier for connections determined based off of environment variables, a tier for um, doing the CRUD work, and then a tier which is the API layer, which calls. I'm not sure. I have to think. Cool. All right. Cool. We have to do a lot more research, and we're definitely learning. This is like day 2 of me trying to research into it. So cool. Thank you guys so much for being here. I'll see you guys tomorrow. Bye, guys.